Hello everyone. Today let's solve the problem maximum subrectangle. Right. So this was asked in Codeforces round 513 by Barcelona Bootcamp. Right. So this is rated for Division 1 and 2. So this was asked in basically this one Codeforces round 513 by Barcelona Bootcamp. Right. So here uh, let's solve this one maximum subrectangle. So you can just go through the question. This is easy to understand. So I'll just summarize the question so that it will be easier for us to solve the problem, right? So what the question states here, we are given two arrays. We are given two arrays. Just give me a second here. 1 second. Yeah, we are given two arrays. One is A and another one is B. These are the two arrays we have been given. One is A and one is B. So we have to create the matrix. We have to create the matrix here. What matrix we have to create here? C of I, J. This is equals to A of I into B of J. Just remember this one. A of I into B of, this is nothing but B of J, right? So we have been given arrays A and B. We have been given an array A and array B. We have to create the matrix M equals C of ij, means C of ij equals A of I into B of J. So that's what we have to create, right? So we have to create the matrix C of ij equals A of I into B of J. So what we need to find here, we need to find the largest subrectangle, means a largest subrectangle in the sense continuous rows and columns, such that the sum of its element is less than or equal to x, such that the sum of its elements is less than or equal to x. So x will be provided in the this one, what do we call, in the question. We don't have to worry about that. So sum of its element has to be less than or equal to x, right? So we have to find the largest subrectangle. So we need to find the largest subrectangle. I'll just write here LSR, nothing but the largest subrectangle whose sum is less than or equal to s, such that sum of its elements is less than or equal to x. So what we need to output here, accordingly with the question, we need to output the maximum area, nothing but rows into columns of such rectangle. So be very careful about this one. So we have to keep this in mind. We are not going with just the this one sum of the elements, right? So we're not just going with the first we'll find the largest subrectangle such that sum of its elements has to be less than or equal to x. We need to output the maximum area. We need to keep this one in the mind. We need to output the maximum area of the such rectangle. So here in this case, what we need to output finally, after finding the maximum, this one largest subrectangle and its sum which is less than or equal to this one x, we need to output the maximum area of such rectangle, nothing but rows into columns of such a subrectangle, right? Constraints we have been given here. You can just look at the constraints, nothing but n comma m we have been given less than or equal to 2000, nothing but, and x we have been given less than or equal to 2 2e9, 2e9, right? Or 2 into 10 to the power of 9. So this one is fine. Constraints n comma n has to be less than or equal to this one, rows and columns has to be less than or equal to 2000, and x, right? X is x should be less than or equal to 2 into 10 to the power of 9, right? 2e9 they have given. So we have to we have to keep in mind about the constraints as well. Rows and columns less than or equal to 2000 and x less than or equal to 2 into 10 to the power of 9. So what is our main goal here? We have to maximize the area under the sum constraint. So we have to maximize the area under the sum constraint. We might get many area accordingly with the rows and columns, right? So we have to go with the maximum area which is less than or equal to x, right? Which is less than or equal to x, basically sum of the this one. First we need to find the largest subrectangle and the sum of its elements which is less than or equal to x. Then we need to output the maximum area of such the rectangle. We might get the minimum this one, most of the this one area, but we need to go with the maximum area which is less than or equal to x. So I hope the question part is completely clear. We have been given two arrays, one is A and B. We need to create the matrix C of ij equals A of I into B of j, right? So this is fine. We have to find the largest subrectangle such that the sum of its element is less than or equal to x, this part. Largest subrectangle whose sum is less than or equal to x. So what we need to output? We need to output the maximum area, that is nothing but rows into columns of such subrectangle. Constraints we have been given here, this one. Rows and columns has to be less than or equal to 2000, nothing but n comma m, and x should be less than or equal to 2e9 or 2 into 10 to the power of 9. So goal, what is our main goal? We have to maximize the area under the some constraint. We have to maximize the area under the some constraint. I hope the question part is completely clear. I hope the question part is completely clear. Let's come to the input part here. Let's come to the input part here. So this is nothing but here. Just give me a second here. I don't want to get confused here. So here, let's come to the first input. So here 3 3 what they have given here. So this one 3 3. So this is nothing but 3. First 3 is nothing but the rows n, and second 3 is nothing but the column. First 3 is rows, the second 3 is nothing but the m, accordingly with the question, right? So n is nothing but rows, m is nothing but the column. We have 3 into 3 matrix. So we have 3 into 3 matrix, right? So here a is nothing but 1 2 3 they have given, b is nothing but 1 2 3. So this is a, this is a. We have to construct the matrix c of ij equals a of I into b of j, right? Accordingly with the question. So this is first line is a and this is b here. So first one is A and this is B. What is 9 here? What does 9 do here? 9 is nothing but the X. Accordingly with the constraint, we have to calculate the max area which is less than or equal to X, right? So this is nothing but X. The line X. I mean the number 9 is nothing but the X here. So here the maximum area or the output that we got here is accordingly with the input 4. Again I'm telling, this 3 first 3 is nothing but the n, this 3 second 3 is nothing but the m, nothing but the rows and columns. 1 2 3 is nothing but the a and b we have discussed. This is a, this is b we have discussed in the question, and 9 is nothing but the x, right? The maximum area has to be less than or equal to 9. Here in this case we got the output 4. Let's see how we got this in the approach. Same goes with the input, this one second input as well. This is x, this is n, this is m, this is a, this is b, and the last one is nothing but 5 is nothing but the x, and the output that we got here is 1. Means the maximum area that we need to get here is should be less than or equal to 5. Basically here we got 1 and here we got 4. It should be less than or equal to 9 here. Basically x is 9 here. For the second input x is 5, right? So I hope the question part and the examples part is completely clear. They have given us wonderful examples just for the sake of understanding, right? So I hope the question part is completely clear. First, what shall we do? Let's discuss the approach, followed by the edge cases one by, followed by the this one complexities, and then let's write the code. Initially, let's discuss the approach first. So here, let's consider the same first example that they have given in the question. So again, I'm telling, so this is nothing but here n rows, this is nothing but the m columns. So this is a and this line is b and this is x. The output that we need to get here is 4. The output that we need to get here is 4, right? So I just didn't write the output part, I think. So output is 4 accordingly with the first question, right? So output that we need to get here is 4, right? So which should be basically maximum area of such subrectangle has to be less than or equal to x. We have been given here x is 9 and maximum area is 4, which is less than or equal to 9 basically, right? So let's see the step by step approach. Let's see the step by step approach here. So here in this case we will be going with the linked list approach. We will be going with the linked list approach to write the code. And also let's discuss the approach right now. Let's discuss the approach. You'll understand how we got the output. Basically, let's consider the same example for the approach as well. So here, first step, we will define the matrix. So accordingly with the question, if you remember, we have to create a matrix C of ij equals A of I into B of j, if you remember, right? So that's what they have given in the question, right? So we will define the matrix initially. C of ij equals A of I into B of j. So full matrix would be here, this one, C equals 1 into 1, 1 into 2, 1 into 3, nothing but here in this case 1 2 3, and here same goes with the 2, this one 3 because we have 1 2 3 1 2 3 here, right? So 1 2 3, so here this one 1 2 3 1 2 3 1 2 3. So here this would be 1 into 1 1 into 2 1 into 3. Same goes with 2 2 into 1 2 into 2 2 into 3. Same goes with 3 3 into 1 3 into 2 3 into 3. Based on this one, C of I j equals A of I into B of j, right? So here it would be 1 2 3 2 4 6 3 6 9. The matrix consists of 1 2 3 2 4 6 and 3 6 9. 2 4 6 and 3 6 9. Now the matrix consists of 1 2 3 2 4 6 and 3 6 9. We have successfully constructed the matrix C of ij equals A of I into B of j. A of I into B of j. Nothing but here this one A of I, B of j. This one again. We have to go with this one, right? 1 into 1 1 into 2 1 into 3 2 into 1 2 into 2 2 into 3 again 3 into 1 3 into 2 3 into 3. So that's what we have done here. 1 2 3 2 4 6 3 6 9. Right? We have successfully constructed the matrix, this one. C of ij equals A of I into B of j. I hope this part is clear. So we are just going with the intuition. So this basically whatever the approach that we are going with, this is the best approach that I have found basically, right? So it's easier to understand, and it's this one. To implement the code also, it is very easy basically. It's similar to the brute force, but yeah, uh, this is very easy to understand. So next part is we will pre-compute the prefix sum of A and B. We will pre-compute the this one. Pre-compute the prefix sums of A and B. Here prefix A and prefix this one. We have the prefix A as well as this should be prefix B, not prefix A. This is prefix B, sorry. So this has to be prefix B. Here we have 0 1 3 6 0 1 3 6 0 1 3 6 and 0 1 3 6. This is the sum of A and this is sum of B. This is sum of A and this is sum of B. Nothing but 3 2 1. We have 3 to 1. Same thing for this one as well, right? 3 to 1 3 to 1. So here in this case 1 uh, pre-computing means here we are just going with initially it would be 0. Initially both would be 0. First we'll get 1 1. Both have 1 here. Next we will sum up this one. 1 plus 2 will be 3. Same goes with B as well. 1 plus 2 will be 3. Next we'll sum up all the three numbers. This one 1 2 3. So this will be 3 4 5 6. So 1 3 6 and 1 3 6. 0 1 3 6 0 1 3 6. Initially it will be 0 0. Next we will consider only one value. Second we'll sum up a this one two values, then we will sum up all the three values. This is how we got here this one. What do we call prefix A and prefix B here? 0 1 3 6 0 1 3 6. Sum of A, sum of B. Nothing but here 0 I 0 I. So this is fine. This is nothing but you just keep in mind that this is sum of A 0 1 3 6. Nothing but the prefix sums. This is prefix sum of A. This is prefix sum of B. Sum of A and sum of B. 0 1 3 6 0 1 3 6. I hope this part is completely clear. Easy calculation, simple math, right? So let's go with the third step here. Let's go with the third step here. We have to find the minimum subarray sums for every possible length. So we have to find the minimum subarray sums for every possible length. For every possible length here. So the length, first one we have here is min of 1 2 3. So this one we can consider for either A or B, right? So here we have the values 1 comma 2 comma 3. So we have to find the minimum subarray sums, right, for every possible length. So we will consider this one. What do we call? um, 1 2 3. So minimum value among 1 2 and 3 is 1, so we'll go with 1. Length 2 is we will be going with this one 1 plus 2 and 2 plus 3, these two and this two, this one and this one, right? So first we considered minimum of all the three values, so this will be 1. Next we are going with the sum of this one and sum of this one. Nothing but this will be 3, this will be 5. Minimum of 3 comma 5 is 3, so we will return 3 here, right? Next we are going with the all the values, sum of all the values. Nothing but here in this case 1 plus 2 plus 3, here nothing but 3 4 5 6 6. So now we got here 1 3 and 6. So length 1 length 2 and length 3. So here now we got the result 6 6, right? So here now we will be going with the 1 nf 1 3 6 1 3 6, right? So 1 nf 1 3 6, right? So just keep this in mind. So this is the step 3, easy calculation. Again for B, we apply the same logic, same thing we get, because the numbers are same. A equals 1 2 3 we have been given, B equals 1 2 3 we have been given, right? So this is A accordingly with the question input, and this is B, same input, so same calculation will get the same thing for the row and column. So this is for the min row, and this is for the min, sorry, this is for the min column. This is for the min column. This is also one NF. This you can consider 136. 136. 1 NF will be putting it at the first, at the beginning, right? 1 NF 136. This is for the row and column. Let's try all the combinations of lengths. So we considered this one 136 first. So we considered for 123. Sorry, this one. So we considered for 1 2 3 3 comma 5 and 6, right? 3 comma 5 and 6. So this is we found here minimum subarray sums for every possible length, right, for the A, and this is for B. Now what we are doing, we are trying all the combinations of length. We are trying all the combinations of length, nothing but I into J. We are trying all the combinations of length, nothing but I into J here. I into J here. So I, we have 1 3 times we are going with, right? So here 1 will consider 3 times. If you remember, in the A we have 1 2 3, and in the B we have 1 2 3 as well. So we will go with 1 3 times, 2 3 times, and 3 times, right? Same thing for the J. We have, we'll go with 1 2 3 1 2 3 1 2 3. So minimum row we already calculated this one, right? 136 we got, 136 we got. So this will be 1 3 times, 3 3 times, and 6 3 times. Same minimum column, this one minimum column J, this will be 136 136 136 136 136 and 136. So the product would be basically here 1 into 1, this one 1 into 1 1 into 3 1 into 6, again 3 into 1 3 into 3, uh, 3 into 6 6 into 1 6 into 3 18, and 6 into 6 36. This one product we are calculating 1 into 1 1 into 3 1 into 6 3 into 1 3 into 3 3 into 6, 6 into 1 6 into 3, and 6 into 6. So the product would be 1 3 6 6 3 9 18 6 18 36, right? 6 into 6, finally 36, 1 to 36. So we have successfully found the product. Next, let's go with the area. Area is nothing but the rows into columns. Area is nothing but rows into columns here, right? So this one would be rows into columns here, I into J. This one would be uh, this one 1 into 1 would be 1, 1 into 2 would be 2, so 1 into 3 would be 3. So next 2 into 1 would be this one. We are multiplying I into J, nothing but rows into columns here. This one 2 into 1 would be 2. This one would be 2 into 2, nothing but 4. This one 2 into 2. Next one 2 into 3 is nothing but 6 here. Next one 3 into 1 is nothing but 3 here. 3 into 2 is nothing but 6 here. The final one is 3 into 3 here. This is nothing but 9. We are going with to calculate the area. We have already discussed this one in the approach, right, or in the question as well. So area is nothing but rows into columns, rows into columns. So same thing, I is nothing but here row, column is nothing but here J, this one column, right? So rows into columns we are doing. Rows into columns is nothing but we get this one, these values 1 2 3 2 4 6 3 9 369. And x in the question, x we have been given 9. So let me come here, just give me a second, let me come to the first one. Yeah, see, x we have been given 9 here. This is A, this part is A, this part is B, this is rows and this is columns, and x we have been given values 9. Accordingly with the question, the maximum area that we have to find, the maximum area should be less than or equal to x, less than or equal to x. So here this one is less than or equal to x. So let me change the color here, just give me a second. So let me go with here some color that is visible. So here, yes, we have got the this one, what do we call, 1 is less than 9. This area satisfies here, right? So just give me a second here, 1 second. So here 1 is less than 9, yes. So 2 is less than 9, So yeah, maximum area, we can consider this one. 3 is less than 9. This one, 3 is less than 9. Yes, we can consider this one as well. Again, 2 is less than 9. Yes, it is less than 9. We will be considering this one as well. 4 is less than 9 here. Yes, 4 is less than 9. This one, 6, we will not be considering 6 here. Will not be considering 6 here. Right. So here, we 6, you can ask here, the value 6 is less than 9, so we have to consider 6 as well, right? So we are not just considering here area. So we will be going with the product that we got as well. Either it should be less than or equal to 9, this one x, right? X in the sense 9. So this one, maximum area, so we'll be considering the product as well. Product here gives us 18. Product here gives us 18 basically. So 18 is greater than 9 along with the area. This is not the maximum area. Maximum area, we have to consider product as well, right? So product here gives 18. Product gives us 18 here. So 18 less than or equal to 9. 18 is not less than or equal to 9. 18 is not less than or equal to 9. So we will not be considering this one. So this is no. This is no. So here in this case, we have the product 6, which is less than or equal to 9. We have the value area 3 here. This we will consider. This we will consider because this 6 is less than or equal to 9. Yes, 6 is less than 9 basically, right? So this satisfy the condition. So we will be considering. Again, see here, we are having the product 6 here, I mean area 6 here. So this will not be considering because we have the product 18, which is greater than 9. We have 36, which is greater than 9. This one also we are not considering. So what are the area we can consider here? 1 2 3 1, this one 1 2 3 2 4 and 3. This one we'll be considering. Among this one, we'll consider the max. We have to go with the maximum area, right? So we will go with uh, in coding, we can just go with math.max of this one, right? So here in this case, we'll go with 1 comma 2 comma 3 2 4 and 3. Max is 4. This we will consider. Maximum is 4, so we will consider 4. The output that we got here is 4. The output that we got here is 4. I hope this part is completely clear. So the best area that we got here is 4, where I equals to 2 and j equals to 2. You can clearly see here, where I equals to 2, j equals to 2. So this one, this part, where I equals to 2 and j equals to 2, right? So this part. So maximum area that we got here is 4. So this we will return as output. So the output that we got here is 4, where I equals to and j equals to, right? So here output that we got here is 4, which is equivalent to the output that they have mentioned for the first example, which is equivalent to the output that they have mentioned for the first example. Here you can clearly see the output that we should get here is 4, right? So the output that we got is 4, which is equivalent to the output that they have given for the example 1, right, in the question. So our approach works absolutely correct. As we are completely familiar with the approach, let's do one thing. Let's discuss the complexities. Let's discuss the complexities very quickly. So what would be the time complexity here? The time complexity would be big O of n square plus m square, right? Nothing but the row square plus column square here, right? N is represented by the row and m is represented by the column here. So here the time complexity would be big O of n square plus m square. Why it is big O of n square plus m square, not the n plus m? Because we will scan all the subarray lengths and the combinations for both arrays. For both arrays, we did in the calculation part, you saw the same thing, right? We will be scanning all the subarray lengths and combinations for both arrays. So this is efficient when n comma m is less than or equal to 2000. So the constraints that they have given, right? So this is efficient when rows comma columns is less than or equal to 2000, or n comma m less than or equal to 2000. Here the total time complexity would be big of n square plus m square, because we'll be scanning the subarray lengths and the all subarray lengths and combinations for both the arrays, for both the arrays, right? So what would be the space complexity then? Here the overall space complexity would be big of n plus m, big of n plus m. Why it is big of n plus m here, the space complexity? Because arrays for the prefix sums and the minimum subarray sums. So uh, we are going with the memory for the arrays for prefix sums and minimum subarray sums both. So the overall space complexity would be big of n plus m here. So the time complexity and the space complexity for the code that we will be writing in the future would be big O of n square plus m square and big O of n plus m. big O of n plus m. So this will be the time complexity and this would be the space complexity. This would be the time complexity and this would be the space complexity. I hope the complexities part is completely clear, right? Now, as we are completely familiar with the approach as well as the complexities, we are good to write the code. Let's start writing the code. So let's do one thing. We have the input output here. We have to go with the fast input and we will be going with the fast input and the fast output. So let's import the input output package. So I'll just go with import java dot input output dot star. So this is fine. And we'll be making use of the utilities. So let's go with the java dot util dot star. This is fine. So the next step here is let's go with the class main here. So I'll just go with public class main. This is fine. Public class main. So within this class, what we'll be doing? Let's go with the main here. Public static void main. Right. So just give me a second here. Yeah, this is fine. So we'll be making use of the. Let me give here throws input output. So this one will be exception. This is fine. So let me delete this one. This is not required one. So just give me a second. So within this class, so what shall we do? First, let's go with the fast input output setup. Nothing but we'll be making use of the buffered reader and print writer. So I'll just go with buffered reader. So br, or let me consider r itself, right? So r equals new buffered reader of new input stream reader of system dot in. This is fine. So the next step is we'll be going with a print writer. So I'll just go with print writer. I'll just consider the variable name output here, out. So this will be new print writer of system dot out. So this is fine. System dot out. This is fine. So the next step here would be reading n and m. So we have to read the n and m, nothing but we have to read the number of rows and columns, right? So for that one, I'll be making use of the string tokenizer. So let me give string here tokenizer. So this would be, I'll just consider this one st, nothing but the string tokenizer here, new string tokenizer r dot this one read line, r dot read line. So this is fine. So this will be int n equals let me go with the integer dot parse int. This is fine. Parse int of st dot next token, next token. This is fine. Intent. So this is fine. This is fine. So next, let me copy the same thing. Let me paste the same thing and make the necessary changes. So this one, instead of n, it would be 1, and this remains same. We're just reading both n and m right here. So this would be same, right? So we are done with the reading n and m. Next step would be we have to read the array using a linked list, right? We will be reading a array using the linked list. So here in this case, let me go with, let's create the linked list here. So this is of the type integer basically. So I'll just go with array list, or this one a list. So this one new linked list. So this is syntax. This is fine. Next step. So let me assign the string tokenizer here, new string tokenizer. So this one string tokenizer of r dot. So let me give here read line. So this is fine. R dot read line. And the next step is let's go with the for loop here. Int I equals 0. So I less than n. Let me increment the I. This is fine. So this one will be a list dot add. So this one will be integer dot. So this one will be percent of st dot. Let me go with the next token. Let me go with the next token. This is fine. So yeah, next let's go with the next step here. Nothing but we have to read the array, this one array b as well, right? So are successful in reading the array A using the linked list. So we were having the array A and B, if you remember, right? So in the first question, we were having the array A, which was 1, 2, 3, and array B was 1, 2, 3 as well, the input I'm speaking of. So we have to read both array A and B here, both array A and B here. So that's what we are doing here. We are successful in reading the array A. Now we have to read the array B as well. So just give me a second here. So let me copy the same thing and make the necessary changes. This is almost similar, almost same actually. So this one will be linked list integer. Instead of A list, let me give B list here, right? This will be new linked list. This is same. So this is same string tokenizer. We are creating the new string tokenizer. R dot readline. This remains same. I equals 0. Instead of I less than n, let me make it m here. I less than m, because we are dealing with the this one columns this time. M I plus plus. So this one will be, instead of uh, A list, this will be B list dot add. So this remains same. Integer dot percent string tokenizer dot next token. This remains same, right? So let's move on with the further steps. Let's move on with the further steps. So now we have to read the x, nothing but the max allowed sum. Here this one will be int x equals integer dot integer dot percent of r dot read line, r dot read line. So this is fine, r dot read line. So the next step would be, we have to convert the linked list to the array for the fast access. We have to convert the linked list to the arrays for the faster access. So let's convert the linked list to the arrays here. So this one, a equals new int of n, nothing but the rows. Same thing for the b as well. So let me copy the same thing here and let me paste it over here. This would be b instead of a, and this would be m instead of n, nothing but the m is nothing but columns, right? So this is fine. So next step is, let me go with idx. Let's initialize the index idx to 0. This is fine. Let's initialize the idx to 0. Let's go with the for loop. So we have to convert the all the this one, right? So all the elements that is present in the linked list to the arrays. So here let's go with the for loop. So let me consider individual value of the a list. Same thing we have to do for the b list as well, whatever we are doing here, right? So this one will be a value of the a list, individual elements. This one, let's increment the index. So here we have to increment the index here. This is fine. Let's assign this one to the value. This is fine. So now we have to do the same thing for the this one as well, b list as well. So let me copy paste the same thing. Index equals 0, value of this one, instead of individual value of b list, we'll consider this one of b of idx plus plus. We have to increment the idx. So we are assigning this one to the value. So this is fine. We are done with converting the this one linked list to arrays for the faster access. I hope this part is clear. We are just going step by step here. So we are just this one, what we are doing here, we are just articulating the same thing in the form of code, whatever we have discussed in the approach, right? The same thing we are articulating in the form of code. So here let's compute the prefix sum for a. Let's compute the prefix sum for a. This would be long, this will be prefix a. So let me go with prefix a equals new long of this one would be this one, n plus 1. This would be n plus 1. Let's go with the for loop here. This one would be int I equals 0, I less than n, and this would be I plus plus. This would be I plus plus. Let's go with the prefix a of I plus 1. This one will be prefix a of I plus a plus I, right? So I plus, so we are appending a plus I. This is fine. So this is fine. What we are doing here, we are just computing the prefix sum for a. After computing the prefix sum for a, we have to do the same thing for the prefix sum b as well. So let me copy the same thing here and let me paste it over here. So this one will be, instead of long of n plus m, this would be column plus 1, right? M plus 1. So here instead of n, this would be m. right? So this is fine. What are the changes we need to do? Instead of prefix a, this would be prefix b this time, right? So here this would be same. um, I plus 1 remains same. I plus 1, I plus 1 equals prefix b of I, prefix b of I plus this one would be, instead of a of I, this would be b of I. So we have successfully computed the prefix sums for a and b. So that's what we did in the calculation part, first calculation part, right? So we successfully computed this one. 1 2 3 1 2 3 we had 1 into 1, again this one 1 into 2 1 into 3. So we went with c of ij equals a of I into b of j, if you remember. So that's, we have to create the matrix. For that one we have to calculate the prefix sum. Prefix sum was calculated in this way, right? 1 into 1, 1 into 2, 1 into 3. Same thing we did for 2 as well. 2 into 1, 2 into 2, 2 into 3. And then 3 into 1, 3 into 2, 3 into 3. So that's what we are doing here. We are, same thing we are articulating in the form of code. We are computing the prefix sums for a and b. We have successfully computed the prefix sums for a and b. Now what we need to do, for each length we have to find the minimum sum of any subarray in a. For each sum we have to compute, for each length, sorry, we have to find the minimum sum of any subarray in a. This would be long long min row equals new long of this one, n plus 1, new long of n plus 1. This would be arrays dot fill of this will be min row, comma, let me go with the long dot max underscore value. So this is fine. So the next step is, let's go with the two for loops. One we have to go for the length, and another one we have to go for the same thing, I and length we have to consider, right? So here we, for each length we are finding the minimum sum of any subarray that is in A. Next, same thing we have to do for B as well. For first, let's do for A. For each length, let's find the minimum sum of any subarray in A. So here on this case, how can I write? Let's go with a simple for loop here. For len equals 1, len less than or equal to n. So this will be len plus plus. So this is fine. So why this is, oh, caps lock is on here. Len, so this one has to be small len, and this one has to be len as well. So here this one is int. So, and for loop also here, for this one has to be small. So this is fine. Let's go with one more for loop as I've said. So this one will be int I equals 0, I plus length here. This one would be less than or equal to n. This would be I plus plus. So within the for loop, what we will do, let's go with the variable sum and assign this one to the prefix a, as we are dealing with the a, right? Subarray in a, right? So we have to find the minimum sum of any subarray in a for the each length, right? So here in this case, let's assign the prefix, this one sum to prefix a of I plus length along with uh, minus of prefix a of I. You would have already guessed this one, right? So this is fine. So let's consider here min row of len, and let's assign this one to the, we have to get the minimum, right? So we have to get the minimum, right? If you remember, we have to get the minimum. So minimum of min row of length and sum. So let me give here math dot min of minimum row of length. Let me copy this one and let me paste it over here. So this is fine, and let me go with the sum. Let me go with the sum. This is fine. So we are done with this. We are done with this. For each length, we are finding the minimum sum of any subarray in A. For each length, we are finding the minimum sum of any subarray in A. So next, for each length, we have to find the minimum sum of any subarray in B, right? So let's go with this. Let's go with this. So just give me a second here. One second. Did I miss out anything? No, right? So let me copy this one. Let me do the same thing for B as well. So this will this will remain same. This will remain same. So instead of the min row, we have to go with the minimum column. We are dealing with the m this time, right? So this one will be new long of m plus 1. So this arrays dot fill remains same. Instead of min row here, let's make this one min column. So this remains long dot max value. So max underscore value, this remains same. Length equals 1, length less than or equal to, so here why the capital N? This has to be small n, man. Even for this one, this has to be small n, right? So caps lock one, caps lock was on, I think. So this one has to be n. Here this one we are dealing with the column, so this one has to be length less than or equal to m. This is fine. Length plus plus, again I equals 0, I plus length less than or equal to not n, this will be m. So this will be I plus plus, this remains same. Again, for the sum we are going with the prefix b, as we are dealing with the b here, right? So prefix b of I plus length, this remains same. This will be prefix b of a, this will be prefix b of I. So this is fine. This is fine. So the next step would be min row. Instead of the min row, we will be having min column. Min row, instead of min row, we will be having min column of length. So min column of length. This is fine. This would be math.min of minimum. Instead of the row we have column here, instead of the row we have column here. So this will be minimum column of length comma sum. This remains same, this remains same, this is fine. So the next step would be, we have to try all the combinations of subarray lengths from A and B. We have to try all the combinations of subarray lengths from A and B, right? So initially, let's do one thing. Let's consider the variable max area and let me initialize this one to the 0, because we have to try all the combinations of subarray lengths, right? From A as well as from B. Let's try from this one, A first. So here, let's go with a simple for loop. Int I equals 1, I less than or equal to n, I plus plus. This is for the A, sublength from A, and one more for loop from B. Also, we have to consider nothing but for J. So here this will be int I j equals 1, j less than or equal to m. So this will be j plus plus. So this is fine. So within the for loop, if the product of minimal sum is less than or equal to x. So here in the calculation table, the maximum that we got was 4, because the product was less than, in the product column, the value has to be less than or equal to x. In our case, for the first example, x was given 9, if you remember, right? So we considered in the product table, we considered all the numbers in the area column, which was basically in the product column, if the value was lesser than or equal to 9, lesser than or equal to 9 for the first example, right? The same thing we are articulating in the form of code here. If product of minimal sum is less than or equal to x, we can afford the area, we can afford that area only. If the product of minimal sum is less than or equal to x, nothing but the product column value, the value that is present in the, was present in the product column, has to be less than or equal to x, then only we can afford the area, this one, area value, the value that was present in the area column, right? So that one we have to articulate in the form of code. In simple terms, let's write the simple if condition here. This would be min row of I, min row of I into min column of j. Then if it is less than or equal to x, if it is less than or equal to x, then what we will do, let's go with the max area equals math.min. Let's go with the max area. This one equals math dot math dot max, basically max area equals math dot max of, again, max area comma this one I into j, I into j. This is fine. So let's come out of this one entirely. So why this is completely fine, so this is fine. So here, finally we are done with the code, we are done with the code. Final step was, I mean, in the approach, the final step was we have to try all the combinations of the subarray lengths from A and B. So how we do it, if the product of the minimal sums is less than or equal to x, then only we can afford the area, right? So in the area we got some numbers 1 2 3 and again 4 and again 3, right? So out of all the things the maximum was 4. Maximum was 4, basically maximum was 4. We considered the maximum. Other things were there, basically 6 and other values were there. We didn't consider 6 3 and some other values, because in the product table the value was greater than 9. The value was greater than 9. We got 18, 36 and all that. We this one discarded that one, because the in the product the value that is present in the product table has to be less than or equal to x, nothing but less than or equal to 9 for the first example, right? Only such area should be considered, and from those values we have to consider the maximum one, nothing but the max area. So here we did the same thing. We articulated the same thing in the form of code. We are done with the logic part. Now we are completely done with the logical part. So we are left with only one thing. We have to output the maximum area, right? So I'll just consider here out dot println. So I'll just go with println here. Println, within the println, let's pass the maximum area. And also let's do one thing, out dot flush here. Out dot flush, we have to flush output, right? So final this one, let's go with the out dot flush. So we have successfully outputted the maximum area. We have successfully output the maximum area. So we are done with this one, right? So we are completely done with the code, input output as well as the logical part. We are completely done with the code. Easy to understand, right? So this is fine. This is fine. This is almost this one brute force, right? So this is fine. So let's do one thing. Before copying this one, let me paste the signature starter template. Let me paste the signature starter template, right? So let's, before copying this one, let's try with the different inputs they have given in the question. So let me copy this one. The output that we need to get here is 4. Let's check whether this code works or not. So here we have error in the line number 41, 47, 48. Oh, we have so many errors. 9 errors. Okay, let's clear this one step by step. In the line number 41 we have variable idx is already defined in the method main string. So here let's come to the line number 41 here, idx. So main, mm, index, we are initializing this one for the first time, right? So it says it is already defined in the method main. So let's go with the line number 47. Let's ignore that one for now. We have prefix of a equals new long of m plus 1. Prefix a is already defined. And why this is showing already defined here? Let's check what is wrong. Here, let's start with this one int for line number 41. So here we have already declared this one, right? Here int idx equals 0. The same thing we have done here. So no need of int I believe. So here this is fine. So let me run this one. Now this error should be gone. Yeah, we're done with this one. Still we have 8 errors. So we, in the line number 47 we have the same thing actually. Variable prefix a is already defined. 47, where is 47? We have already defined this one long prefix a here in the line number 44. Here we don't have to define this one again. So here prefix a is enough. So here prefix a is enough, right? So this one would be fine. So let me run this one again. So yeah, now let's come to the line number 48 here. What we have done here, cannot find the symbol. I think here, so yeah, this has to be prefix b, I think. Not this one. We are assigning this one to the this one long prefix b. Basically this has to be prefix b, I think, not the prefix a. Prefix a we have already done here. The same thing we are doing with the b list here, right? Yeah, this has to be prefix b. Now let's run this one. Yeah, now we have two errors basically. One is at the line number 47. Again line number 47. What error we have? Error not a statement. Error not a statement. Why? Prefix b equals no longer of m plus 1. We have done this one, right? So I hope this part has to be fine. So let me come to the line number 51 here. So I saw this one. So this one has to be capital actually, not max dot value. I don't know whether this works with this one as well, but this has to be capital always. So this is fine. Thank God I saw this one. Yeah, this one, let me change this one, max underscore value. So this has to be capital basically. This is fine. Let me run this one again. Now this works. No, right? So yeah, same error we have. So the line number 47, what is? I'm not able to understand. Not a statement. Semicolon accepted. We have the semicolon here, right? So what is wrong here? So this one, why I have given equals here? Yeah, yeah. Now this has to work. Now still we have one error. Error cannot find the symbol. So this C has to be capital. You can clearly see here. I have misspelled this one. Not misspelled basically. This has to be capital C. Line number 71. This has to be column. So this is fine. Let me run this one. So yeah, now we are getting the output 4. We are getting the output 4, which is absolutely correct, right? So thank God. So this is fine. So let me copy this one and let me paste it over here. So we have to get the output 1. Let's see whether we get the same output or not. So here you can clearly see the output that we are getting here as 1. The output that we are getting here as 1. So for both the inputs, the output works absolutely correct. I mean, this one, the code works absolutely correct, right? So our input are working correctly, right? So we are getting the desired output accordingly with the input. So our code works absolutely correct. So let me do one thing. Let me copy the entire thing and let me paste it over here. So this is C itself, right? Problem C. Yeah. So we have selected C already. Let me hit the submit button. I hope this works for all the test cases, man. Let's see. Let's wait for some time. Here you can clearly see running on test one, right? This is very slow, man. Running on test case 17, 18. So let's wait for some time. This is actually the brute force, man. Basically, I wanted to strictly make use of this one, what do we call linked list, right, for this particular problem. Linked list problems are very, this thing, very rare in the code forces. So we can solve certain problems via using linked list, but especially linked list problems are very rare. So I just wanted to solve this problem, however, using the linked list. So again, we are converting the linked list to the array, right? So here, even it is brute force. So that is the reason we went with a long, this one, long code for this particular problem, or else we would have directly solved this one with other methods easily, right? So we are doing the same thing by considering a b again and again and again, right? So I hope this part is completely clear. See here, the code got accepted, right? So whatever the code that we have written is completely, I hope whatever the code that we have written is completely clear. I mean, I hope the solution part is completely clear along with the this one, what do we call, complexities and approach, right? For now, this is it. Thanks for watching, guys.